question on momentum and collision. One, they said a ball of mass 2 kg moves with a velocity 5 meters per second. Find its momentum. A ball of mass 2 kg move with a velocity of what? 5 meters per second. Find its momentum. You already know that the mass of the ball is 2 kg. The velocity is what? 5 meters per second. And the momentum denoted by P. Note that P is equals to what? mv. That's mass times velocity. So we just said the mass, which is 2 times velocity, that's 5. So we multiply, that's 10 kg meter per second. So the momentum is 10 kg per meter per second. And note, it is in the direction of the motion. So that's how to do that particular question. Very simple question. So this is another question on it. We said a constant force of 10 Newton act on a body for 0.5 seconds. Find the impulse and the change in momentum. Here we shouldn't disturb ourselves. We already know that the impulse is also the change in the momentum. So meaning that the moment we get the impulse, we already gotten our change in momentum. So now let's solve this question. We have the force is equals to 10 Newton. Our change in time is equals to 0.5 seconds. Then the impulse denoted by J is equals to F change in T. So J is equals to 10 times 0.5, which is 5 Newton seconds. So the impulse is equals to change in momentum. So that's our impulse. Our momentum, the change in momentum, which is that at P, is equals to 5 kg meter per second. So the impulse is 5 Newton and change in momentum is 5 kg meter per second. Now to the third question. Another question on it, a very interesting question. Is that a 3 kg body moving at 4 meters per second collide elastically with a 2 kg stationary body. So this body is moving. The first body is moving while the second body is what? Stationary. Now find their velocity after collision. This is a perfect elastic 1D collision. Why? Because why it refers to as 1D? Because the other body is stationary while one of the body is moving. So that means there is only one direction. So it's only moving in a single direction. Okay. Now let's solve the question. We have our m1, which is mass of the ball of the first body, to 3 kg. The velocity 4 meters per second. While the mass of the stationary body 2 kg and the initial velocity 0, because it's not yet moving. So this is a perfectly elastic 1D collision. So now our V1 is equals to m1 minus m2. So this is a formula we can use in calculating the final velocity. So it's a derived formula, is derived from the equation. So we have V1 is equals to m1 u1, m1 minus m2 over m1 plus m2 u1, then plus 2m2 over m1 plus m2 u2. So this is a formula. I derived this formula actually that we can use in calculating a perfectly elastic 1D collision. So the V1 will be m1 minus m2 over m1 plus m2, then multiplied by u1 plus 2m2 over m1 plus m2 multiplied by u2. So from there we can easily actually get our V1. So we already know all these numbers. So that will be 3 minus 2 over 3 plus 2 times 4 plus 2 times 3 over 3 plus 2 times 0. Now you know this 0 cancel on this side. So we're having 3 minus 2 over 5 times 4. And that is equals to 0.8 meter per second. So that's for V1. Now let's go and calculate V2. V2 is equals to calculate V2 now, there will be a change in the formula now, because V1, you know, something like this in the front is in the front for V1. So which is m1 minus m2 over m1 plus m2 u1, something like that. But this one we have 2m1 over m1 plus m2 u1 plus m2 minus m1, not m1 minus m2 now, m2 minus m1 over m1 plus m2 multiplied by u2. So this is the formula for calculating V2 for perfectly elastic 1D collision. So now our V2 is equals to all this giving us 6 over 5. You know this u2 is 0, so all this side is already 0. So that will just be 6 over 5, 2 times 3, that's 6 over 5, 2 plus 3, then times 4 plus 0, and the answer here is 4.8. So that means the final velocity V1 and V2 are 0.8 meter per second and 4.8 meter per second. So the two final velocity that we are being asked to calculate is 0.8 meter per second for the first one, and v2, which is 4.8 meter per second, the second one.